Hello, good evening, guys, and here is Dr. Pooja for you to clear all your concepts related to physics, chemistry, or biology. And today we have selected a very interesting topic, which is gravitation. So we will be talking about everything related to gravitation. What is gravitational constant? What is gravitation or gravity or acceleration due to gravity? All right, so this all are we are going to discuss in no time. Okay, so let's get started. Let's crack it. Okay, so here we go. So what will we study today? So we will be studying, as I said, let me select a color for you. So we will be talking about gravitation. So in this chapter, I will walk you through how this concept of gravitation is related to, the force and other things that we have discussed or we have, studied in our previous chapters. Okay, like force and motion and velocity, right? All these things we have already talked about in our previous sections. So why gravitation? Okay, why are we going to study gravitation after we discuss the force and the motion and all other chapters? All right, so that is one thing that we will discuss, and this is chapter 9 for grade 9 physics. Okay, so again, description is like we have to discuss or we will discuss what is gravitation, what is force, what is pressure, what is, all those things we will discuss in a minute. All right, so let's get started. So first of all, sorry, I don't have a picture here. So you need to know me, like who am I and why am I taking your lectures on Unacademy. So first of all, my name is Dr. Pooja. If you have not followed me on Unacademy's platform, go ahead and do that, because I am a science educator on Unacademy, and I take care of your physics, chemistry, and biology. Okay, so these are all the subjects I teach on Unacademy's platform. And if you guys are not aware of my recent course that I've launched for you all, that is my revision course. Okay, and that is good for 9th grade students and 10th grade students. Go ahead and sign up for that revision course. All right, a little bit about myself. So I've done a PhD in biotechnology, and I carry 8 years of experience as a scientist and as a lab director in the United States of America. Now I'm back in India, and I wanted to teach you guys so that most of you understand the concept of science, so that science is no more a difficult subject for you all. Okay, so that was the whole idea. That is why I started this thing on Unacademy. All right, so I guess you are ready to get started with to understand this concept of gravitation. All right, and before we get into all that, here is my code, guys. Go ahead and sign up with my code, which is PS13, if you want to take extra 10% discount on Unacademy, which is having multiple options for you. And we now not only teaching you the academics part of it, we are also taking care of, we have a creative corner for you where it is the overall development of you as a person. Okay, so you can go ahead and subscribe for plus subscription on Unacademy, and there are other various options available that I will discuss in a minute after I talk a little bit more about gravitation, and once I'm done with this gravitation part. Okay, so let's get started. Here you go. So gravitation, you all must have heard about what is gravitation, but before I start talking about gravitation, let's discuss what we have done in previous chapters, right? In previous chapters, we talked about motion, we talked about speed and velocity, and we have also talked about acceleration, right? So why in this gravitation chapter, yes, Mr. Papu, I guess, I'm not sure, this is a YouTube channel, so I guess it's running on YouTube only. So yes, why this is the discussion about gravitation, and why am I talking about motion and speed and velocity and acceleration and all those things? Because we know that in our previous chapters we talked about force, right? And from the force, what do we mean by force? Force is, we said, when something changes somebody's or something's direction or magnitude of speed. If it is stationary and we apply some force, it starts moving. And let's say if it is moving and we apply some force, we can change its speed, we can slow it down, or maybe we can change direction, or maybe we can change shape, right? So this is the concept that we'll discuss a little later, right? So that means if you look around, right, if you look around yourself, have you ever noticed, because Newton noticed that. I know we all know this story of Newton where an beautiful red apple fell down, okay, and Newton was the person, he's like, uh-oh, why is it coming down and why is it not flying up? So that means there is something in the earth which is attracting this apple towards itself, okay. From there Newton got that idea in his mind, like there is some kind of force which is attracting apple or anything which is falling down towards itself, all right. And from there he started thinking, okay, if apple is getting attracted towards earth, is apple also attracting earth towards it? Okay, then he looked around and then he was like, how about this moon? If earth can attract an apple towards itself, it can also attract the moon, right? It can also attract the moon towards itself. But then why moon is not falling on the earth, right? That should be the next question. Why, if earth is attracting, let's say this is our big earth and here is our moon, and if earth can attract apple, why can't it attract moon? And why don't moon fall on the earth? Okay, so that is the question. So it means it is not just the earth that attracts moon towards itself, right? It is not just the earth that attracts the moon towards itself, but moon also attracts the earth itself towards itself. There are other planets, I guess I spelled it wrong. There are other planets which are attracting moon towards them. There is sun present, okay, it attracts everything, sun, moon, earth, other planets. So all in all, what do we have to understand here? Everything is attracting everything else towards itself, right? Let's say you are sitting in the room, you are attracting all those chairs and tables and fan and AC and TV and bed, everything towards yourself. And all these things which are sitting in the room, they are also attracting everything else towards itself. So it's kind of balances out. And that's why things, they don't, collide with each other. Okay, so this is what we call gravitation, right? Everything attracts everything else towards itself, and this is called gravitation. But next question, with what force? If we said, okay, everything is attracting everything else towards itself, with what magnitude of the force? Okay, how is it attracting other things towards itself. What is the magnitude of that force? Okay, and what are the different factors? What is the magnitude of this force? What are the other factors on which this force depends, right? So these are like various points that must raise, or these are the questions which must be there in your mind, like why is this all happening, right? If there is a force, what is the magnitude? What are the factors on which this force depends upon? All right, so let's discuss, and I will take a very basic example. I'll take an example of, let's say two balls are present. All right, let's say we have a ball, a bigger one, and then we have another ball, a smaller one. All right, and these balls, they have their center over here. Okay, and let's say they're just sitting on a ground. I'm sorry, I couldn't. Let's say they are sitting on the. So now, if gravitation is true, then this ball A must attract a ball B towards itself. We are ignoring like other things are also present on these balls and they're also attracting these two balls towards them. We are just ignoring that fact. Okay, so we are going to focus on this point. Let's say we have these two balls, ball A and B, and this one is having mass M. I'll just say this one is with mass M, and this one is with mass smaller m, right? And there is a distance between them. I'm so sorry. Can I just hold on? Okay, I'm so sorry. It just took off my whole ball thing. Anyways, I'll try it again. Let's consider it's a round ball, and this is the distance d between these two balls. Okay, so now with what force, okay, these two balls, they are attracting each other towards each other. Okay, so we have this force which is directly proportional to the mass m of the bigger ball and m of the smaller ball. Means if they have more mass, then they will attract each other with a greater force. If they have less mass, they will attract each other towards each other with a lesser force. So that is what this constant of proportionality means. It is directly proportional. Force is directly proportional to the product of the masses of the two objects or the two balls. All right. And force is also, this force that we are talking about is also inversely proportional to the square root of the distance between these two. And how are we going to take the distance? Are we going to take it from here, from the center, or how? Yes, we are going to take the distance from the center of these two objects, from these two balls. We are not going to take it from the surface. We are going to take it from the surface. All right. So that is the thing, like force is inversely proportional to the distance between the two objects. So how do we write it then? We write it F is proportional to product of the masses and square root of the distance between these two balls or these two objects, whatever you want to call it. I'm just calling them balls because it's easy to understand. Now we don't like this constant of proportion constant. We want everything in equal sign, so that is easy to calculate. So we have this constant of proportionality, which is F is equal to G m upon d square. So what is this g? So g is constant of proportionality, and we call it gravitational constant. That is our gravitational constant. Okay, how do we calculate it then? We want this gravitational constant, which is g is equal to f into d square mass and mass. All right, so from here, and if you want to calculate the units of this, what would be the units? G is equal to, we know that force is in newtons, distance is in meters, so it's meter square, mass is in kilograms, so there are two masses, it is kilogram square because there are two, and it is per square. So this is the unit, or these are the units for your constant of proportionality, which is your gravitational universal constant of gravitation. Okay, so this is the with the force, like you have to multiply, okay, with this number if you want to calculate the force between two objects. Now, what is the value for G? Okay, so value for G, how do we calculate it? We know that, yes, you will be able to, it's not something which is very difficult, Papu. F is equal, G is equal to F into, we have G square divided by mass and mass. So when we do all these calculations, so we have this gravitational constant, which the value for that is, let me get it real quick for you, 6.7673 into 10 to the minus 11, right? And that is Newton meter square. This is the value for G. All right. I belong to Chandigarh. I'm from India only. Right? So this is what we get the value for G. And as this is a universal gravitational constant, you will always find the value equal to this. Does not matter where you are. Okay, does not matter where you are. This is going to be constant anywhere you go. All right, so this is one thing that I wanted to discuss with you, like what is gravitational constant and how do we calculate it. Now, next important point, I'll just erase this thing off from this. Okay, so next is very important, what is free fall. You remember I started this lecture starting with what is, speed and velocity and acceleration and all those things, and then I said this is like impacted by some kind of force. If force is there, it can change the speed or change the velocity, and rate of change of speed or velocity is called acceleration, right? So it all depends upon the force. So here we were talking about this force in our previous chapters. When we covered, we were talking about force on an horizontal surface. right? That is when we were talking about, because you remember we had all these, we have cars moving, please excuse my car. So, and we were calculating what is the rate of change of velocity, or what is the acceleration if this car is moving on a road, right? What is the, if driver applies the brakes, what is the retardation, all those things we discussed in our previous chapters. Motion. Now, what if something is there on a, let's say, pole or on a wall, and it falls down? Let's say this is a ball over here and it falls down. Even then, like in this case, the car was having a velocity, the car was covering a distance, the car was covering that distance in a given time. There was change in velocity, we called it acceleration, right? But the only difference was it was on a horizontal surface. Now, what about if something is false? Something falls means in a vertical case. Like we are not moving like this, we are moving like this now. Will there be change in the speed, or let's say velocity? Will there be change in the direction of motion, right? If the answer to this is yes, so that means there is some kind of force working on that object also, and that is that natural force that is working. What do we call that natural force? Because if the objects are falling down, if let's say this object is falling down, or the ball over here is falling down, and its speed is changing, okay, velocity or speed, I'm just interchanging these two, otherwise it's velocity because it has direction, right? If it is changing, so that means there is some force which is acting on it, which is pulling it down, and we call that force, because it is changing the speed, it's changing the speed of the object, because here the object was at rest, and as it's falling, its velocity changes, and if its velocity is changing, that means there is some kind of acceleration. But as there is no external force applying on it, there is just acceleration, and this acceleration is due to what? This acceleration is due to, I will write a word here, then you will know that. Gravity, right? And this is what we call acceleration due to gravity. And what is that? What is this acceleration due to gravity? This is an object when it is falling down, okay, there is a force acting on it, and that is due to Earth's gravity. And as it is falling down and there is a force acting on it, we call this acceleration as acceleration due to gravity. Alright? And this is called free fall. As there is no change in the direction of the falling object, But yes, of course, there is change in velocity. And this acceleration due to gravity we represent it with small g. And the gravitational constant, as I said, that we represent by capital G. Right? That is gravitational constant, universal gravitational constant. And this is acceleration due to gravity. And guys, you need to understand the units for these two. For this one, it was Newton meter square per kilogram square. And as this is an acceleration, yes, of course. But the thing is, Papu, if something is falling down and if we don't consider the friction due to the air, then whatever it is, it will fall with the same speed. Okay. So, and because it's acceleration, there is no mass number, because momentum is what? Momentum is P is equal to mv, right? But acceleration is equal to rate of change of velocity per unit time. And if there is no mass unit over here, it is not going to change, right? And of course, if we don't consider the factor of, let's say, because momentum will ultimately depend upon the mass, right? But here, if the things are falling down and they're falling without the presence of, let's say, air friction, they will fall with the same speed. Okay, so G is acceleration. So the unit of acceleration are same as meter per second square. Okay, so these two things are what you have to remember. So now, as we calculated the value for G, now we'll have to calculate the value for G. What is the magnitude? What is the value for G? All right, and let's calculate G. What is the acceleration due to gravity? So we know that. Okay, so we know that to calculate this, we know that F is equal to force of gravitation is equal to F is equal to G, mass of one object, another object, and square of the distance between them, right? And we also know that F is equal to M into G. How does it matter, Gaurav? Right? So here is this, why we have kept like G is, this is acceleration due to gravity. Okay, so from these two equations, if we, because these are the representations for force is equal to this and force is equal to this, that means this is equal to this. Okay, so let's have that number. Let me change the color of my pen. So G M M upon D square is equal to M into G, right? And because we have to calculate the value for G, correct? So what we will do, these two M's cancel out. Yes, I'm married. So here, what do we want to do? So let's first have the pictorial representation. So in this, what we are trying to say is, there is Earth, because we are trying to find out acceleration due to gravity, right? So that means we have to have Earth, because that acceleration is due to gravitational pull of Earth. So this is our Earth. I'll just color it a little blue for you so that you know it's Earth. It's not just a ball, right? This is our beautiful Earth. And we want to cover, guys, why I'm drawing this is I want to explain something very important. So now let's say we have, hello Abhimanyu Gaurav, come on. Hello Ashok Kumar Sharma. So here is an object, let's say this one, small ball. Hello, 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 Abhimanyu and all, is falling down. Here is the center. Give me a second, guys. Give me a second, please. Okay. All right. So now we want to see like this object with mass m is falling down towards Earth, whose mass is m. Okay, and here is the distance between the center of the Earth and center of the object. So this distance is r. R is the radius. R is the radius of Earth. Okay. M is mass of the object and capital M is mass of Earth. So guys, now you have to understand this, because we are considering, because when we calculated this G, right, at that time we considered that it is, I don't know, square root of the distance between the center of the two objects, right? Now as compared to the center of the Earth, okay, this distance is very, very small, right? So we will not consider the center of object from the center of the Earth. We'll just replace this with radius of the Earth, okay, because radius of the Earth is like too big as compared to, just a second. Hello Vipin. So radius of the Earth is way too greater than the radius of the object. Okay, so we are just considering it r square. So what will be the value? Let me erase this Earth now. I'm great, Vipin. You are late today. I've covered so many points. And today our videos are working fine. Okay, so now we will have our, because as I said, Gm divided by r square is equal to G, right? Because the radius of the Earth is too large as compared to the radius or the distance from the center of your object. So the value for G would be 6.7 into 10 to the power minus 11, and I will not write down the, let's say, the units, just to omit confusion. 6 into, that is the mass of the Earth, 10 to the power 24 kgs, divided by, I'm just taking these numbers from the book because I don't remember them. So the radius of the Earth would be, and if you are given this numerical or something, you will be given these values, don't worry, right? Square. So once we calculate all this, it's easy to solve. You don't have to really be worried about solving it. You're going to get to solve it. Okay, so the value of this would be 9.8 meter per second square. Alright, so the point that you have to remember here is, if in the numericals this value is mentioned, So then you need to take this value in the numericals, and let's say if this value is not mentioned in your numericals, then even you can take, to keep it simple, 10 meter per second square as the value for G. Okay, but I would recommend you guys preferably go for this number, go for this value. Okay, so that is all about, what is acceleration. Because you are late, Vipin. If you really want to understand like how this value came, then you need to go back and watch this video again. Then you will get to know like how we got to these values. Okay, it's pretty easy. You can get it after you just go over this. And similarly, if we talk about like what is the, now let's so we have done free fall and we have done acceleration due to gravity. Now other most important topic, we will try to understand this. Another most important question is that we always get, what is mass and what is weight? What is the difference between these two? What is the difference between mass and weight? And we are always confused when we talk about weight, because always since childhood we know and we talk about or we discuss, my weight is this much, my weight is that much, right? So technically it is not your weight that we are discussing. Weight in physics is force. Okay, and I will explain in a minute. Yes, absolutely, Mr. Perfect. Okay, so weight is actually the force and mass is actually the content. Okay, that is actually the matter present in something. Okay, so let's say we have we take example of Mr. Vipin Kumar. So let's say this is our earth, and let's say over here is moon, and this is our earth, and over here is space. Okay, so it's okay, Abhimanyu, how does it matter? 3 students or 4 students or 5 students, how does it matter? You want to learn something, you stay here and learn. You don't want to learn something, you can leave the class. As simple as that. You don't have to be worried about how many students are there. That is my point of worry, not yours. Okay, and if you really want to see like how many students come to my class, you need to take subscription for Unacademy. Okay, only then you will learn the difference, because at Unacademy we not only teach them physics or chemistry or biology. At Unacademy we teach our students how to respect other teachers, right? We make them a perfect human being, we make them a perfect person. We don't teach them to go to other teachers' classes and start talking about some other platforms. So this is what we teach our students at Unacademy. Okay, we don't only make them toppers, we make them perfect human beings. All right, and I hope you understand that. And if you still don't understand, then you must subscribe for Unacademy to understand how it works at Unacademy. All right, what kind of quality of educators we have at Unacademy and what kind of quality we give to this world, whosoever comes out of Unacademy. Okay, you need to understand this point, and for that you have to sign up. All right, and I don't want to discuss too much here. For that you need to come to my class. Anyways, so Vipin, I was talking about how much you weigh, Vipin. What is your mass, total mass? So let's say Vipin weighs 50 kgs maybe. So if Vipin weighs 50 kgs, then mass of Vipin is equal to 50 kgs. Vipin stays on Earth. He's going to weigh 50 kgs. He goes to moon and he decides to stay there. He will still weigh 50 kgs. And if he says, no, I don't want to go anywhere, I just want to roam around in the space, he will still be 50 kgs. Alright? And this is what we call mass. Right? The real content of you, the mass of you, the matter present in you is the mass. Okay? And that is what we measure in kilograms. That is the unit of mass that in which we measure our mass. Alright? So that is there. But now what is weight? Let's talk about it. What is weight? Quickly. So weight, first of all, is not mass. Right? Weight is what? Weight is the force with which the planet or the object attracts something towards itself. So it is a force. It is not the content present in you. Okay? For example, Vipin is here, over here on Earth. The force with which Earth pulls Vipin towards itself is called weight of Vipin. Okay? And we know that the force is equal to m into g. And what is this m? This m is this mass. Okay? That mass that Vipin has. So it was 50 kgs. And Vipin is pulled towards Earth with the force which is equal to 10 meter per second square, which is your acceleration due to gravity. That is the force with which Earth pulls it towards towards itself. So we'll have 10 and the answer would be 500 newtons. So if Vipin is weighing, if the mass of the Vipin is 50 kg on Earth, his mass or his weight is going to be 500 newtons on Earth. Right? So this one over here that I have drawn is, this one is Vipin's weight and this one is Vipin's mass. Right? And in your book and when we do all those calculations, we'll get to know what is the force with which moon attracts things towards itself. What is the acceleration due to gravity of moon? Okay, and it is 1/6 of that of Earth. Just remember that. You can do all those calculations in your book. So if Vipin had weighed 500 Newton over here, it will be 1/6 of that 500 Newton divided by 6 on moon. Right? Alright. And how about in space? What will be the weight of Vipin in space where there is no planet? Okay, I will talk about it, Vipin, just a second. So here there is no gravity. In space there is no gravity because you are not standing on any planet. You are not standing on anything. You are just free floating in vacuum in space. And the value for G is 0. And as the value of G is 0, your weight will be 50 into 0 is going to be 0 Newton. There will be 0 Newton force on you in space. So that's why you will be floating freely in space. because there is no force of gravity holding you on the surface. Okay, so that is the difference between mass and weight. And quickly, if we want to summarize, if we want to differentiate between what is the difference between mass and weight, here we have mass is the actual content, the actual matter present in something. And weight is what? Weight is the force with which a planet, for example, attracts. It is not a planet, it is something. Attracts towards itself. Right? Now, as it is the content, the unit for this is kgs, and as this is the force, the unit for this is Newton. I will write Newton. As this is the content, it is going to be constant no matter where you go, because you are you. Okay, it is going to be the same. As compared to this, weight is going to change depending upon the acceleration due to gravity of that place. All right, for example, I showed you 3 examples of Earth, Moon and space. And here mass, we measure mass in, as I said, in kgs, and this one we do it in newtons, and this is a constant quantity, and this one changes from place to place. All right, so this was all about, quickly, about the mass and the weight and what the difference between these two. All right, so next we will talk quickly about what is thrust and what is pressure. Okay, and before we do the recap, let me go back one more time. And here. Okay. Here we will talk about what is pressure or thrust. We will talk about. Right? Now let's say if I ask you to have this nail, acceleration is within rate of change in velocity. I don't have that structure. Wait a second. Okay, now let's say we have this nail, right? And we have this nail, and I want you guys, this is a wooden log, okay? And I want you guys to hammer this nail into the wood. Okay, that is what I want you guys to do. So what will you do? You get this hammer and you start hammering it, right? You have this hammer and you start hammering it, and similarly this one, you have this hammer and you start hammering these two. So what will happen? Here, in case A and in case B, a nail will get into the wooden block, right? In B, impossible, right? No matter you are applying same force. Let's say you are applying 10 Newton force in case A and in case B. You will get this nail into the wood here, but you will not get it into the wood here. Why? You are still applying the same amount of force. Reason is, it is not just the force, it is force per unit area that matters. Why? Because here whole force is concentrated on one point and it gets into the wood. Here that force gets distributed all over the place of this nail. So per unit area force in this case is less. Per unit area in this case the force is more. Okay, so that means this is what we call pressure. Okay, force working per unit area is called pressure. Here we have that force working on per unit area. Same force is working on lesser area, right? So let me explain again. How do we do it? Just a second. Okay, I'm here. Let me erase this. So if we keep the force same, let me give you a very good, nice example. If the force is same, if the same force is working on the greater area, there will be less pressure. Okay? And if the same force is working on a smaller area, there will be more pressure. You got to remember this because these two are inversely proportional. So less area, more pressure. More area, less pressure. And this will help you to answer many questions like why is it easy for you to cut an apple with a knife from one side and not from the another side? Why the tanks, they are always on the chains? Why can't we have those tanks without chains, right? So these are the important points that you can answer depending upon this. Force per unit area is like the pressure. Now what is this thing thirst? Have you ever questioned yourself? What is this thing thirst? So now let's say, let me take off this couple of things from the sheet. Let's take away these. And I will also, take away this. Okay, just to clear it a little bit, to explain more things. All right. So now let's say we have that same nail over here. Right? Now let's say you are trying to hammer it this side. Right? You have this hammer and you are trying to hammer it from the side. Do you think this nail will go inside the wood? Not at all. Why? Because this force is not acting perpendicular to the surface, right? So this is not thrust. So this is what we call thrust. The force which is working at right angle to the surface is called thrust. If you are trying to hammer this nail from the side, it will not work because that is not thrust. So today, with this, I will end this session. You can ask me anything: what, why, where, when, who, how, right? Related to this chapter, gravitation, where we started with discussing G, which is universal gravitational constant. Then we talked about G, which is acceleration due to gravity. We talked about mass. We talked about weight. Then we talked about pressure. Then we talked about thrust in this chapter. So quickly, if you want to understand all these terms, what are they, how they work, what do they do, then you need to watch this video 1 or 2 times again. Okay, and if you still have any questions, you are more than welcome to answer those questions. Hello Pranav and Sai and Abhishek, hello, good evening. So you can ask me these questions, and if you don't have any questions, you can go back to Unacademy and you can sign up for our plus courses. In plus courses, I personally cover physics, chemistry and biology, and I'm a science educator on Unacademy, and here is my code if you want to enroll for my upcoming courses. So that was like, the homework for you is to do all the numericals where we talk about you have to calculate all those numericals where you have acceleration due to gravity, what is the final velocity, what is the initial velocity. Okay, so all these numericals is your homework, and if you are facing issues calculating those numericals, always come back to our platform and we will help you with all the different type of numericals, issues, problems, anything that you're facing. And guys, here are our new subscription plans. They are amazing, they are awesome, from class 9th to class 12th plus subscription. And if you do that, you will get our creative corner for free. Okay, go ahead, plan earlier and join with us. We have test series, we have practice questions, doubt solving live classes, we have weekly quizzes, and we have live subjects, live classes on all the subjects for you guys. All right, सारे डाउट क्लियर करती हूँ, but for that you have to come to our session on Unacademy. Okay, you need to join us now, and if you want to take plus or iconic subscription, use my code PS13. Okay, and these are the different pricing options available for you. Go ahead and pick one. All right, and this is our creative corner, which is something really new. You get Vedic math, doodling, public speaking, origami, magic tricks, poetry, storytelling, robotics, mnemonics, and debating. All right, and this is all up and running, and this is something very, very different from all other platforms. What are you waiting for, guys? Go ahead and sign up for Unacademy's plus courses for Unacademy's, because we have all the languages. We cover classes in Hindi as well as in English. I'm an English educator, and guys, do follow me on Unacademy. Here is my name, Dr. Pooja Sharma. All right, I'll see you guys there, and with this I end today's session. Thank you so much for watching me. Thank you so much for present here in this session. You guys have an awesome evening. Take care. Bye-bye and good